Welcome to the video on the Introduction to Cloud Computing and Networking Basics. This is Lesson 1, Introduction to Cloud Computing. We will cover a variety of topics, including the evolution, key characteristics, service, and deployment models of cloud computing. We'll also discuss providers, use cases, risks, and future trends. By the end of this video, you will be able to define cloud computing, differentiate between service models, identify real-life examples, and recognize the benefits and challenges of the cloud. Cloud computing is the delivery of computing services over the internet, offering faster innovation, flexible resources, and economies of scale. Key points include paying only for services used and accessing resources anytime, anywhere, without managing physical infrastructure. Examples of cloud computing in daily life include Google Drive for storage, Netflix for streaming, and Gmail for email. Think of it like electricity. You use the service and pay the bill without owning the power plant. Reasons for adopting the cloud include cost efficiency with pay-as-you-go pricing, scalability to meet demand, and accessibility and mobility for remote teams. It also provides speed and agility for quick deployment and faster time to market. Further reasons for adopting the cloud include built-in reliability and backup, automatic updates and security patches managed by the provider, and the ability for organizations to focus on their core business instead of managing IT infrastructure. Cloud computing evolved from the mainframe era of time-sharing to the early web, introducing virtualization. Key phases include the rise of SaaS, the launch of IaaS with AWS in 2006, and today's integration with AI and IoT in the smart cloud. Key characteristics of cloud computing include on-demand self-service, allowing users to manage resources without human interaction. Resource pooling enables multiple clients to share physical resources securely. Rapid elasticity means IT resources can easily scale up or down based on user needs. The remaining key characteristics are low maintenance cost, as organizations don't need to set up physical data centers. Additionally, the pay-as-you-go model ensures users only pay for the resources they actually utilize. Cloud computing architecture is comprised of a front end and a back end, connected via the internet. The front end is the client infrastructure, and the back end consists of applications, services, storage, and security components. The front end handles user interaction through thin and fat clients. The back-end platforms, often called the cloud computing engine, include servers for storage and processing, providing the core power and capacity of the cloud. The three main types of cloud service models are IaaS, PaaS, and SaaS. IaaS is like renting land, PaaS is like renting a house, and SaaS is comparable to renting a hotel room. Infrastructure as a service, or IaaS, provides virtualized IT infrastructure over the internet, allowing users to rent resources instead of owning hardware. Users manage applications and data, while the provider manages the underlying hardware, storage, and networking. Platform as a Service, or PaaS, offers a ready-to-use development and deployment environment. Developers can build and manage applications without worrying about the underlying infrastructure. Key features include automatic scaling, load balancing, and support for multiple programming languages. Software as a Service, or SaaS, delivers fully functional applications over the internet, accessible via a web browser without installation. The provider manages everything, and key features include no setup required, automatic updates, and access from any device. Popular SaaS examples include Gmail for email, Zoom for video conferencing, Google Docs for document editing, and Dropbox for cloud storage. Microsoft 365 offers online office tools, and Canva is a graphic design application. Let's check your knowledge of cloud service models. First, which is an example of PaaS? The correct answer is B, Google App Engine. Second, which model allows users to manage only the application and data? The correct answer is C, PaaS. Next, we will cover cloud deployment models. There are four main models: private cloud, public cloud, community cloud, and hybrid cloud. We'll examine each one in detail. A public cloud offers services and infrastructure hosted by third-party providers, shared among multiple customers over the internet on a pay-per-use basis. It features shared resources, scalability, and is cost-effective, much like using public transportation. Use cases for the public cloud include hosting websites, application development and testing, and data backup and recovery. Examples of major public cloud providers are listed here. Advantages of the public cloud include lower costs, fast deployment, high reliability, and remote access. Limitations include less control over data and security, potential performance issues due to shared infrastructure, and difficulty meeting specific compliance needs. A private cloud is dedicated to a single organization, offering cloud benefits like scalability but restricted access. It features exclusive access, custom security, and dedicated infrastructure, but it's more expensive, like owning a house. Private clouds are used by companies with strict data security, compliance, or performance needs. Advantages include full control over data and enhanced security. Limitations include high upfront costs and the need for in-house expertise. Time for a knowledge check. First, which is a key feature of a public cloud? The answer is C. Shared infrastructure among multiple users. Second, which cloud type offers greater control over data and infrastructure? The answer is B. Private cloud. This slide visually contrasts the characteristics of public and private clouds, highlighting their differences in management, security, cost, and ownership. A community cloud is shared by several organizations with common interests, such as regulatory or security concerns. Key characteristics include shared access, common goals, collaborative management, and cost sharing, similar to a gated community. Community clouds are useful for organizations with joint compliance requirements, consortiums, and public sector agencies. They are cost-effective and promote collaboration. However, they have limited scalability and require trust among participants. A hybrid cloud combines public and private cloud platforms, allowing data and applications to be shared between them. It offers flexibility, scalability, and control. Examples include storing sensitive data in a private cloud, while using a public cloud for analytics or managing traffic spikes. Hybrid clouds are ideal for enterprises with compliance or security needs, those requiring cost-effective scalability, companies migrating to the cloud, and for backup and disaster recovery. Advantages include high flexibility and better security for sensitive operations. Cloud computing offers numerous benefits. It is cost-effective, scalable to easily meet demand changes, accessible from any location or device, and reliable due to built-in disaster recovery. Maintenance is minimal with automatic updates, and it promotes faster innovation. Cloud computing is applied across many sectors. In education, cloud-based tools enable remote learning. Healthcare uses EHR for patient data access. Entertainment platforms like Netflix rely on the cloud for global media streaming. Businesses use cloud-based CRM systems for scalable tools. Risks and challenges of cloud computing include data security and privacy concerns, as sensitive data is stored off-site, necessitating careful compliance. There is also an internet dependency risk, where service disruptions can impact access and productivity. Downtime from provider outages is another major challenge. Additional challenges include vendor lock-in, where moving providers is complex and costly. There is also the issue of hidden costs, with unexpected charges for bandwidth or usage spikes. Cloud computing contrasts with traditional computing in several key areas, particularly regarding ownership, maintenance, cost structure, scalability, and resource availability. Future trends include edge computing, which brings data processing closer to the source to reduce latency. AI and machine learning are increasingly integrated as a service, and serverless computing allows developers to deploy code without managing infrastructure. Other future trends include cloud gaming, where game processing is streamed from the cloud, reducing hardware needs. We are also seeing early access to quantum computing via the cloud to support complex simulations and research. This concludes Lesson 1. We will now move on to Lesson 2, Computer Networking Basics. A computer network is a group of two or more devices connected to communicate and share resources, such as files and printers. Examples range from your home Wi-Fi network to the global internet. The key benefits of networking include shared resources like printers, fast communication, and centralized management. Networks are composed of hardware, software, and people. Networks are categorized by size. Personal area networks, or PANs, cover a small area. Local area networks, or LANs, connect devices in a confined area. Wide area networks, or WANs, span a large geographic area. Network topology refers to the arrangement or physical layout of devices and connections in a network. Understanding topology is crucial for network efficiency and resilience. There are different types of network topologies. The bus, ring, and star topologies are the most common physical arrangements, each with specific advantages and disadvantages regarding cost, setup, and fault tolerance. Common network devices include routers, which manage traffic between networks, switches, which connect devices within a network, and network interface cards, or NICs, which enable devices to connect to a network.